Folks, welcome to Statistics. What's up, folks? Welcome to the next lecture of statistics today. Alright, folks, so today we're going to look at random variables in statistics. Okay, so random variables are variables whose outcomes you cannot determine. So our example is that you have a company that produces computers and you have 15 computers in stock. So let's get a smaller thickness. So you have 15 computers in stock, and we're going to represent those 15 computers by a 5x3 grid. Now, of those 15 computers, some are bad and some are good, and the bad ones we're going to represent with green. So let's shade in the bad computers with some green, and we'll call those computers refurbished. So that means they used to be old, but now they've been converted into new. The good computers, the ones that the customers want, we represent in blue. And these are the new computers. These are the fresh out of box computers. And these are the new computers. So you can see we have 11 of these new computers. So there are three situations. If your customer gets no blue computers, you're gonna lose $1,000. If your customer gets only one blue computer, you'll lose only $100. And if he gets all the blue computers, you'll lose no dollar. So let me paint out a clear picture for you. Here's the clear picture. There's three scenarios. Okay, let's call it scenarios. Scenario number one is when the customer gets 0 new computers. That means you lose out $1,000. Okay, that's your loss. If he gets 1 new computer, you lose out only $100, so 10 times less in magnitude. And if he gets all the new computers, then as you might expect, you lose no money. Now our goal is to find, what is our goal? Our goal is to determine the expected value of your loss. How much will you lose on average? So to answer that question, we have to find the probability of each of these three scenarios. So how do we do that? Well, to find these probabilities, I'm going to take you into 4 cases. So we can have a refurbished computer, or we can start with a brand new computer. Okay, so let's first calculate the probabilities of these two, the two basic cases. So what's the probability you can get a new computer? Well, there's 11 new computers. Can you see that? If you count it up, there's 11 blue boxes here. So that's going to give you 11 over 15 as a probability for a new computer. For a refurbished computer, however, there's only 3 of those, or rather we should have drawn 4. So this was also supposed to be new, refurbished. Okay, so then your probability for that is 4 over 15. 4 green out of 15 total. Okay, but you're shipping 2 computers, so you can also have more possibilities. You can have refurbished, which is the worst case scenario. The possibility that your second computer is a refurbished, well, what is that? You've already picked one refurbished, so your total number of refurbished computers is going to go down by 1. Do you see that? Because if this one strikes out, you have only 3 left. But if you have 3 left, you also have 1 less total computer, so 15 would be reduced to 14. Okay, well, there's another scenario. Instead, you could have a refurbished and a new computer. In that case, what would be the scenario? Well, you'd still have 1 less computer, but you'd have still the same number of new computers, 11. Okay, let's try to do the same scenarios with this one. You can go with a new computer, which is the best case scenario, a new and a new, but you'd be reducing both your new computers and the total number of computers you have. And let's take the second case scenario, which is you pick a new computer and then a refurbished computer. Well, that's going to start out as 11 over 15, but then you still have 4 out of 14 of these refurbished computers left. So it looks like I'm going to have to zoom in to right out over here, but there we go. So you have 4 out of 14 of those. So now we can finally calculate the probability of these, okay? So now what we can do is come over here, write down our probabilities. So what's the probability of 0 news? Well, 0 news means double refurbished. So that's the probability. Sorry, let's make that less thick. That's the probability. If you ship 0 news, essentially what you're shipping is 2 refurbished. Okay, so what's that? Well, what's that going to be? Well, it's 4 over 15 times 3 over 14. 4 over 15 times 3 over 14. All right, second scenario. How about you ship 1 new? Well, 1 new is the same as the probability of shipping 1 refurbished and 1 new, plus the probability of shipping 1 new, 1 refurbished. Well, what's that going to be? Well, check it out. I'm going to highlight these for you. If I highlight these for you, hopefully you can see that. That's either this path of new and refurbished or refurbished and new. Okay, so with that in mind, let's fill in our probabilities here. So what's our probabilities going to be? Well, refurbished new, what's refurbished new? It's 4 over 15 times 11 over 14. 11 over 14. Plus, new refurbished is 11 over 15 plus 4 over 14. Okay, and finally, our final one is going to be the probability of shipping 2 news, which is your best case scenario. So that's the probability of shipping new and new, which is going to be what? 11 over 15 times 10 over 14. Now, we have all of the information we need to calculate the expected value. Okay, hopefully we don't have some jargon on the left. So, what is the formula for expected value? What is the formula for expected value? Well, expected value is given by the summation of a product. And what product? It's going to be the probability of a scenario times whatever value the scenario contains. So what's that going to be? Well, it's going to be $1,000 times 4 over 15 times 3 over 14. That's your first scenario. But let's keep it going. We have many more. We have 100 times the probability of refurbished new plus new refurbished. So that's going to be 4 over 15 times 11 over 14 plus, don't forget, the new refurbished. That's 11 over 15 times 4 over 14. And finally, your last case scenario, your best case scenario, if you ship 2 new, that's going to be 0 times whatever. But nonetheless, for the sake of pedanticness, we can go ahead and write it down. 11 over 15 times 10 over 14. And if you multiply all that out, that's going to give you your final expected value of what? Of $98.90. And that's the expected loss. Okay, well, that's the minimum zoom level. But that's the expected loss you can expect if you hope to sell your computers. All right, folks, that's it for this lecture on statistics and random variables. We'll check you out on the next lecture of statistics. Thank you.
Ambition plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.